Hello, this is Ms. DB. In this video, we're going to look at some examples from the 11.5 worksheet on angle relationships in circles. So we're going to be learning some similar theorems to what we did in 11.4. In fact, this first one really could just be a corollary to that one. The theorem we learned in 11.4 was that an inscribed angle is half of the measure of its intercepted arc. Well, this is really an inscribed angle, except that it's formed by a tangent and a secant, or it could be a chord, that intersect right on the circle. And at that point of tangency, the measure of this angle will be half of the measure of its intercepted arc. So the only difference is how this angle was formed. And so it will be half of the measure of the arc all the way from here back down to the vertex of the angle, which looks a little different too. So if you know this arc from here to here, then you can take half of that to find the measure of angle ABC. This is an example using that. You can see that the measure of angle BCD is just half of 142. You can also use it the other way to find the measure of an arc. This arc all the way from here to here will be twice as big as the angle ACD, which is marked 90 degrees, so you can double the 90 degrees to get 180. So for each of these, you're going to be finding either an angle or an arc. So there's not a lot of work to show, but there's a little bit. So for this first one, measure of angle FGH, so that's this angle here, it will be half of, using the theorem, the measure of the intercepted arc, which goes all the way from here to here. So I'm just going to type that this angle is equal to 1/2 of 216, which is 108. Half of it is the same as dividing by 2. Right, I was correct. So that would be 108 degrees. If you want to make a degree symbol while typing, you can use that little exponent button and put a lowercase o. It looks very similar to a degree. There's also a degree, if you insert a symbol, you can get a degree symbol from there, but the exponent with the little o works quite well. This one, they want us to find two things. The first one is the measure of angle FGH, which is right here. The second one is arc IJ. Now, when you're typing, it's hard to make the curved line over it, so I wrote that we're looking for arc IJ. That's what it would look like if I was handwriting it. So arc IJ is this arc from here to here. And again, it looks a little strange, but the angle that it belongs to is the 75 degrees. So remember that that angle of 75 degrees is half of the arc. So since you're looking for an arc, you will double this, or you could write that arc IJ is equal to 1/2 of the angle measure. Wait, the arc, I gotta look at the theorem again. The theorem is that the angle is 1/2 of the arc. So I wrote that backwards. The angle of IJK is equal to 1/2 of the measure of arc IJ. And what I know is that the angle is 75 degrees. So if this is equal to 1/2 of arc IJ, I could multiply both sides by 2 in order to solve this. So 2 times 175 is going to equal arc IJ, because 1/2 times 2 will cancel over there. All right, moving on. There's another theorem that says that if you have two secancer chords intersecting in the interior, this is not the center, it's just somewhere in the interior of the circle, the measure of each angle formed is half the sum of the measures of the intercepted arcs. You need to know this measure and this measure. If you add them together and divide by 2, you will find the measure of angle 1. Now, because these are vertical angles, that will equal the measure of angle CED if you needed that one instead or as well. So in this example problem, you can see they know this is 32 and they know this is 100, and they're looking for the measure of angle SQR, which is this angle here. And that will be equal to the sum of 32 plus 100, and then divide that by 2, or take half of it. Now sometimes you'll be looking for this one, and you'll have to do a little bit more work. Let's look at some more examples. Number JML, that's going to be directly found W or YUX. Here's an example where we're looking for this angle, but we're not given any of the measures of the arcs that belong to that. So to solve this one, we'll go ahead and find the measure of angle VUY instead, because together these two angles form a straight line. So I'm not going to find this one yet. I'll have to wait a minute. First, I'm going to find the measure of angle VUY. Angle VUY will be equal to half of the measure of the sum of the intercepted arcs here and here. So 68 plus 94. Once I find this answer, that will be this angle right here again. Oh no, that would be this angle right here. And then I will subtract from 180 to find the measure of the angle they're asking me to find. So 68 plus, was it 94? 94 is equal to 162, and half of 162 is 81. So that's the measure of angle VUY. But I need to find the measure of angle VU or YUX to answer the question. Together, these two angles form 180 degrees. They're a linear pair. So to find this, you'll take 180 minus the measure of the angle we just found. All right, if a tangent and a secant, like in this first example, or two tangents or two secants meet in the exterior of a circle, see, all of these meet outside of the circle, then the measure of the angle formed, this angle here, is half the difference of the measures of the intercepted arc. So you have to find the measure of this arc, and then you subtract this arc. You have to find the measure of this arc, and then subtract the measure of this arc. In this one, it's the whole circle will be used. 360 degrees will be used. Find the measure of this arc, and then subtract the measure of this arc. So you'll be subtracting, taking half to find these solutions. There's some good examples here, 3 examples to look over, and then you have these problems to solve. So make sure you show your work. Let's look at number 6. In number 6, which is very much like number 8, the theorem says that x will be equal to half of the big arc minus the small arc. And they only give us 1 degree. They give us that the small arc is 1/16. What's the big one? We can find the big one because this uses up the entire circle. So the big one is, the whole circle is 360 minus 1/16. That will give us the measure of the other arc. Minus 1/16 is 244. So that means from here all the way over to here is 244 degrees, this piece, this big arc. So I can substitute that into my equation. So this will be equal to 1/2 of 244 minus 116. And then you can finish that up. Number 8 will be just like this. Number 5 is a little bit different too. No, 5 is going to be easy. Take the big arc minus the small arc, and then take half of that. And number 7 gives us the same information. Now number 9 is a little bit different, because this time they give us the angle measure, and we know that we're going to take 1/2 of the big arc minus the small arc to answer this. Now, since the x is kind of trapped in here, let's start by multiplying both sides by 2 in order to get rid of the 1/2. The opposite of multiplying by 1/2 is multiplying by 2. So 2 times 27 is 54. These will cancel, and I'll just be left with x minus 40. And you can use that to find the measure of arc x. In this one, we're looking for an arc. In this one, again, they're giving you the angle, so it'll be 35 equals 108 minus x, and then you have to take half of that. So again, it'll be very much similar to the one we just did. You'll start by multiplying both sides by 2. Pretty much the same thing for this one as well. In this one, in order to find this angle, it's a whole circle, so the big arc is going to be 360 minus x. And the little arc is x. So the formula is that the measure of the angle, which we know is 38, will be equal to 1/2 of the big arc, which is 360 minus x, minus the little arc, and we're trying to find x. So to solve this, let's combine our like terms, and we'd get 360 minus 2x, and then multiply both sides by 2 to undo the 1/2. So 2 times 38 would be 76 equals 360 minus 2x. And then we'll subtract 360 from both sides. And then when we divide by a -2, you'll have a negative divided by a negative, which will be positive. So your x will become positive when you solve that. Okay, these are just some review of the different things that can happen depending on where the angle is. So if the vertex of the angle is on the circle, then it's half the measure of its intercepted arc, whether that was formed by an angle here or whether it's formed with a tangent and a line. Doesn't matter. If the intersection happens inside the circle, then you would add the two related arcs together and divide by 2. And if the intersection happens outside the circle, then you subtract the arcs and take half. So that's a review of all the different theorems that you've had in the last couple chapters. For the last 3 problems, you're going to match the equation that you would use to find the angle measure to the picture that goes with it. There's also a journal in this week that's related to this section. So if you're having any trouble with the journal, go back and look at the theorems that are here and in the textbook so that you can review what you need to know for those. All right, that's it for today. Thanks a lot.